Hi there, today we are learning about angles, some basic properties of angles and basic angle pairs. We're going to start with some basic vocabulary of angles, first being vertex. Vertex is the point where two or more lines meet. In this case, point B right here is the vertex. The angle is the figure formed by two rays with the same endpoint, and the rays form the sides of the angle and the endpoint of that both rays where they meet, that is the vertex. Here we have example of an angle, and let's look at some ways that we can name this angle. We see it's made up of ray BA and ray BC here at vertex B. We can name this angle ABC. We can name this angle CBA. Because we only have one angle that has this vertex, we can call this angle angle B, naming it by its vertex. Or because this angle is named here with a 1, we could also call it angle 1. Here's some things that are not acceptable. We could not call this angle CAB. The vertex has to be the middle point when you're naming. We also couldn't call it angle A. It's not the vertex point of the angle. Therefore, you would not call this angle angle A or angle C. One way that we measure angles is in degrees. And it has a symbol of the little, oops, my ink kind of smudged together, but it's a little circle. You can see some examples here. To indicate the size or degree of an angle, you write a lowercase m in front of the angle symbol. This stands for the measure of. Let's look at some angles that have varying angle measures and see how we can classify them based on their angle measures. And hopefully this is a review for you, but it's a good refresher. A right angle is an angle that measures exactly 90 degrees, and we've got our little circle here to indicate that it's in degrees. It is marked with the box in the corner to show you that it's a 90-degree angle. A straight angle is an angle that measures exactly 180 degrees. Two rays that form a straight line. An acute angle is an angle that measures between 0 degrees and 90 degrees. And an obtuse angle is an angle that measures between 90 degrees and 180 degrees. Again, hopefully that's a review. Let's look just down here. Practice identifying angles by their angle classification. So matching the terms acute, right, obtuse, and straight to the angles. We have angle A here is a large angle. It's open wide. It is greater, its measure is greater than 90 degrees, but less than 180. So angle A is our obtuse angle. Angle B here is marked with that box, like I mentioned here for our right angle. Angle B is a right angle. Angle C, we have two rays here that meet to form a straight line, has a measure of 180 degrees. This is our straight angle. And angle D has a measure of less than 90 degrees but greater than 0. It is acute. Now we have some other examples. First, to sketch and label a figure to fit the descriptions. We have a straight angle, angle DBC. I'm going to let you have a chance. You can pause this or go ahead and sketch your own label. And then angle 2, oops, I've got a typo here, is an acute angle, angle MNT. Go ahead and do both of those, and then I'll come back and give you an example of what those could look like. Yours may not look exactly like mine, but should be something similar. It has the properties correct. Here in this next example, it says name angle DBC 2 other ways. So we've got angle DBC. 2 other ways that we could possibly label this are angle CBD, or we could name this angle 2 based on the way that the angle is labeled. We could not just call angle DBC angle B because it has a vertex. B is also the vertex of this angle ABD or angle DBA. And since you can't differentiate which one you would be talking about if you called it angle B, you cannot call this just angle B here. Which leads us to the next example. Can angle 1 also be named angle B? Why or why not? Can angle 1 here just be called angle B? And like I was saying in the last example, we cannot because there are other angles that have the vertex. Actually, there are 3 of them. So there's angle ABD, has B as its vertex. Angle DBC has B as its vertex, and angle ABC has B as its vertex. So there are 3 angles whose vertex is B. And so you would not be able to call any of those angles just angle B. All right, let's look at some basic angle pairs. Again, we're going to start with some vocabulary and some examples of new vocabulary. This may be a review, or some of these may be a review, but really important to know moving forward whenever you're working with angles. Vertical angles are first. Vertical angles are the opposite and congruent angles formed by intersecting lines. So we've got 2 lines or line segments or rays or any parts of lines that intersect. They form 4 angles. The opposite angles are called vertical angles. When they are formed by intersecting lines, like this example, the opposite angles are congruent to each other. So here we have angle 1 and angle blank are vertical. Your opposite angles, angle 1 and angle 3, are your vertical angles. And then we have angle 4 and angle, the opposite one is 2. And it tells us that they are congruent, so I'm going to just kind of mark those as congruent, and then we could do the same with angle 2 and angle 4. Adjacent angles. Adjacent angles are coplanar angles, which means they're in the same plane, that share a side and a vertex with no common interior points. Any points that they share on the inside of those angles. So adjacent means, just like if you're talking about like The neighbor that is adjacent to you. They are right next to you. They share a fence line with you. Or you're a partner that is adjacent to you, like they sit right next to you. So your adjacent means right next to. So angle 1 is here. An angle that is adjacent to it, sharing a side, a vertex with no common interior points, would be angle 2. But angle 1 also has an angle on the other side of it. It's sharing this side with angle 4. They are also adjacent. Another example, we've got angle 3 here is adjacent to angle 2, and 3 is also adjacent to angle 4. Complementary angles are two angles whose measures have a sum is important here, of 90 degrees. Each angle is called the complement of each other. So in our first example here, we have a diagram. We see that we have our right angle box. Right angle box indicates that it's a 90-degree angle. And so we've got an angle 1 here adjacent to an angle 2 here. So the measure of this angle 1 plus the measure of this angle 2 have a sum of 90 degrees. So angle 1 and angle 2 are complementary. They don't have to be adjacent though. Any two angles that have a sum of 90 degrees, and in this case 50 plus 40 adds up to 90. So these are also complementary angles. So you can see them in two kind of different ways. Supplementary angles are similar, but just a little bit different. Supplementary angles are two angles whose measures have a sum. Again, we are adding up the measures of their angles. Their sum is 180 degrees. Each angle is called the supplement of the other. Again, we have a couple of examples to show you what some supplementary angles look like. They have a sum of 180 degrees, which is our straight line. And so if we've got two angles that are sitting here together on a straight line, the measure of angle 1 plus the measure of angle 2 add up to this 180 degrees. That makes them supplementary. Again, just like our complementary angles, they don't have to be adjacent to each other. They can be separate. This angle, angle A, has a measure of 90 degrees. Angle B has a measure of 90 degrees. 90 plus 90 equals 180 degrees. So angle A and angle B are also supplementary here. A linear pair is our last type of basic angle pair. And a linear pair is whenever you have supplementary angles that are also adjacent. So we've got adjacent angles, so they are touching or right next to each other, and supplementary, they have a sum of 180 degrees. So this example here is an example of a linear pair because they are supplementary and adjacent. So sometimes it may get difficult for you to recall the difference between the terms complementary and supplementary and which one adds up to 90 degrees and which one adds up to 180 degrees. And so I have this helpful little reminder for you. Complementary starts with a C. So I'm just going to kind of highlight this C. And that motion of the complementary from the C makes up the 9 in 90 degrees. Whereas the S in supplementary can help you remember that is the same as the S in the 180 degrees, making up the 8 So you can kind of help you remember complementary angles have a sum of 90 degrees, supplementary angles have a sum of 180 degrees. All right, let's do some practice. Our first example, we have a diagram. The directions say to name the indicated angle pairs. So we've got some intersecting lines here. I see a right angle mark here. I see this ray here creating some extra angles. Let's see what the questions want us to do. Just name them. So we've got angle ABD. So that is angle ABD here. And angle DBE. Angle DBE. So I've got this one and this one. The first thing I notice is that they share this side here. That makes them adjacent. And I've got a 90-degree angle. I don't know the measure of angle DBE, so I cannot give it any other name that we have above. So this angle pair is just adjacent. That's all that they share. Number 2, CBE and angle EBD. They are sitting next to each other, so they are adjacent. But I also notice that if this angle here is 90 degrees and this is a straight line, that means this angle here is also 90 degrees because 90 plus 90 is 180, which means that these two angles have a sum of 90 degrees. And what do we know about angles that have a sum of 90 degrees? They are also complementary. Lastly, we have angle FBA and angle DBC. So I see that this line here is intersecting this line here. And I've got this angle compared to this angle. Those are formed by intersecting lines and they are opposite and congruent. Those angles are called vertical. All right, example. Angle ABD and angle BDE are complementary. So that means they have a sum of 90 degrees. The measure, here's our first indication of what we were talking about on the last set of notes about the little lowercase m sitting next to the angle ABD indicates that we're talking about the measure of angle ABD. Has a measure of 5y plus 1, and the measure of angle BDE has a measure of 3y minus 7 degrees. Find the measure of angle ABD. So that's the one here. But I can use what I've got here to algebraically find that actual measure. I know that since it's complementary, they have a sum of 90 degrees. So I can add 5y plus 1 to 3y minus 7, and they add up to a sum of 90 degrees. So I've taken the measure of angle ABD here and added it to the measure of angle BDE here and set them equal to 90 degrees because I know that they are complementary. So then I can simplify and solve this equation. 5y plus 3y is 8y. 1 minus 7 is negative 6. I'm going to add 6 to both sides. Divide both sides by 8. And I find that y is equal to 12. That's not what the question's asking though. It wants me to find the measure of angle ABD. That's this one. So I'm going to substitute y back in. And 5 times 12 is 61 plus 1. The measure of angle ABD is 61 degrees. All right, last one. Now we've got these two angles, same angles, different problem. They are now supplementary. So I can apply exactly what I did here, except for they're supplementary, which means they have a sum of 180 degrees and different angle measures. ABD is now 3x plus 12. Angle BDE is 7x minus 38. And they have a sum of 180 degrees. Again, we're going to simplify and solve this equation. 3x plus 7x is 10x. 12 minus 38. Oh, I have a typo. 12 minus 38 is, double check my math here, negative 26 equals 180. I'm going to add 26 to both sides, and I get 206 over here. Divide both sides by 10. X is equal to 20.6. And then I am going to plug the value of X back in to, I want to find ABD. I'm running out of room. So I've got 3, I'm going to plug it in, 20.6 plus 12. 3 times 20.6 is 61.8 plus 12. And the measure of angle ABD is 73.8 degrees. Almost ran out of room. All right, thanks for watching. Good luck with all of your angle pairs.